Thank you, Jeff. Yes, I have become quite the fan of lithium iron phosphate batteries. And let's begin by a little bit of a definition. What is a lithium iron phosphate battery? There can be a number of different abbreviations when you see them referenced. LiFePO, Life. They are state-of-the-art, but state-of-the-art in this case, it's been around a while. BioNO developed or kind of came into business in the 2012 timeframe. Many of the batteries that were deployed at that time are still working today. The nominal voltage for these batteries is ideal for ham radio applications at 12.8 volts. And these battery chemistries is totally different than lithium ion or lithium polymer, lithium cobalt oxide, some names that I'm not familiar with. It's important for us to not confuse them. Now, in the course of my presentation, I'm going to be referring to and taking advantage of a number of slides from BioNO themselves. I reached out to the principal at BioNO and got permission to use his slides, for which I'm very appreciative. And if I show a slide that has, in the lower right-hand corner, the BioNO logo, then you know that I'm using one of their slides. Now, I'm going to interject some of my own opinions and comments, and here's one. I'm going to call this a quick market assessment. This is somewhat tongue-in-cheek. Here's the market assessment. There are good ones and there are bad ones. You can't tell by looking at them. If you've had a chance, I've had a chance to look on the internet and YouTube and find some evaluations for some of these lithium iron phosphate batteries, and it can be pretty interesting. K8MRD has done a number of these videos, and in the course of his video, he takes these batteries apart physically. He breaks them apart and does an analysis. And if you go and you can kind of check these out, it becomes pretty interesting, because what he and others have discovered is that sometimes the specifications in terms of what these batteries can and cannot do are not matched to the components in the batteries. So, now, having said that, on the other hand, there are a lot of good brands for lithium iron phosphate batteries. A general observation that I've made is there are a lot of really big ones. It's almost easier to find 50 amp hour batteries. You can find 100 amp hour batteries. And I'm speculating a little bit that the market is kind of going to using these batteries for RV use, vehicle use. You can buy a lithium iron phosphate battery for your automotive vehicle. So it's a big market out there. A general observation I would make is that when you see the price of a battery, also have in mind whether you need a compatible charger. And I'm going to talk about compatible chargers. After I comment in general how I use these batteries. Now, in general, I'm going to define 3 applications for these batteries, the first of which is field use out on a POTA site, linking in a solar charger. I don't have a solar charger myself. I'm not going to be talking in depth about field use of these batteries other than I've used it in the field, I've plugged it in, hooked it up, it works fine. I'm specifically going to be talking about what I do for my home power and what I do in my vehicle for mobile battery use. So here's what I do at home. And afterwards, you can come up here and look at the front table. I brought in 2 of my batteries, and they're shown here. I use for my ICOM 7300, I use a 15 amp hour battery, and I have bought, it's a Bioenno-Power battery. I am a Bioenno-Power fanboy. And I use their 4-amp charger. I have their charger plugged in all the time, and it works great. It works so well that I've rehomed, I've sold all of my 30-amp power supplies. I don't have any left. In the lower part of these slides, lower left-hand corner of the slides, you can see the price for a 15-amp hour. This is the list price. A 15-amp hour battery with the Bioenno power charger comes in around 175 bucks. That pretty nice 30-amp power supply I show comes in for 120 bucks. So it's cost me more, but as you'll see a little bit later, I think it's really worth it for me, my application in the long run. Now, my making this change has not come without a downside, and I'll comment on that a little bit later. But this is how I operate my 7300. Those of you that know me know that I also have an Elecraft radio. I have a 30-amp hour battery for my Elecraft radio. Here's how I operate the Yaesu FTM500 in my car. I've got a little battery under the seat. It's a Bioenno Power, 6-amp hour battery. I have a 2-amp AC charger. My vehicle has one of those inverters. Maybe yours does too, and you've never figured out a use for it. But I plug my Bioenno Power 2-amp power supply into that. I've got it connected to my battery, and the Yaesu radio is plugged into that, and it works great. Now, if I didn't have the inverter in my vehicle, I might use another product available from Bioenno Power, a DC converter. It is required that you use something like that. You can't just plug a cable into the 10-amp cigarette or accessory socket in your vehicle and expect it to work. You need an adapter like that. So the cost that we're looking at here, the AC charger and battery comes in around 100 bucks. The DC adapter itself is about 100 bucks, so that's a $200 total. Now there are options. One of the options, of course, is to plug in your radio into the accessory outlet only. That does have a 10-amp max, and if you're using that particular radio, that radio requires a 12-amp maximum current draw when you're operating at 50 watts. So the benefit of my using a little battery under the seat is that I can operate the radio at full power. Another option, and I know some of you have implemented that option, and that's to put a hole through the firewall and run a DC cable from your battery. There are special considerations for it if you have one of the newer cars like I do. I've got one of these cars. I hate this feature. It's that feature where the vehicle will automatically turn off at a stoplight and turn back on again. From what I've read, that special feature introduces some complications when you pull power off your battery for radio applications. So for me, the additional cost of the Bioenno Power battery has been worth it. Well, why am I able to operate this way? And it has to do with a number of the advantages, the unique advantages of lithium iron phosphate batteries. Now, I'm primarily going to be looking at the second column on this slide. This slide compares the lithium iron phosphate batteries to sealed lead acid, but I'm just going to focus here on the center column. The first of which is that these batteries are very safe. They are safe as a result of the unique chemical bonds. They are non-toxic. They don't have some of the problems that lithium-ion, lithium polymer batteries have. As you probably know, and just out of curiosity, I'm going to ask for a show of hands. Raise your hand if you have a lithium iron phosphate batteries. Okay, there are about 80–90% of us in the room have these batteries. And likely one of the reasons you bought these batteries is because they're very lightweight. They are 50–60% lighter. Here's another big advantage. The number of cycles that these batteries support, 2,000 to 3,000 cycles and sometimes more. Every lithium iron phosphate battery, whether LiFePO4 or another manufacturer's, has a little circuit board built into it. And that circuit board, sometimes called a battery management system, sometimes called a protection circuit module, provides additional protections for that battery. And those protections include protecting against overcurrent, over discharge, under voltage, over voltage. Lithium iron phosphate batteries should not be charged below 32 degrees Fahrenheit. And a battery protection circuit, a good battery protection circuit, also includes a temperature transducer to determine what the battery is. Remember, I referenced some of those YouTube videos you can look at to see evaluations. There are lithium iron phosphate batteries on the market which, while they have a battery protection circuit built in them, don't have the transducer to test for temperature. Yeah, there's a comment here.
On that battery cycle, you mentioned to me when it says 2,000 cycles, you have it plugged in all the time, you use it a little bit in your car, that's a fraction of a cycle, correct?
Yes.
So it's really, it's going to outlive yourself, probably.
Say that again.
I said, because it'll probably outlive me. The battery will outlive me.
Right. Right. Well, there's another benefit of the battery chemistries, and that benefit is a little bit of a discharge is not a whole discharge, to your point. And so if you discharge the battery 10%, that's not a full discharge cycle, and you can discharge it many times at 10%. This is why the battery is uniquely qualified. It's a great battery for amateur radio use because you can discharge it a little bit in the course of operation. If you remember my example here for the battery I use for my IC7300, I have a 15 amp hour battery and I have a 4 amp charger on it. I'll comment a little bit, but there are times when the IC7300, when transmitting, draws more than 4 amps. So the benefit in terms of the effect of partial cycling, because they can be partially cycled, because they can be charged and discharged to less capacity, these are fantastic batteries for the application. There is a nominal self-discharge of 2 to 3% per year. This is a LiFePO4 slide. You can see their logo in the lower right-hand corner. I've added one piece of information to it. What's great about these batteries is a very slow discharge. For almost 95% of the battery capacity, it's going to be operating above 10 volts. That battery management circuit that I mentioned typically has a cutoff of 10 volts in it. So the battery never gets discharged to zero because of that protection circuit. Now, that having been said, my IC7300 will cut off if the power is below 11.7 volts. It's very hard to read on this particular slide. The vertical axis is voltage, the bottom axis is time, and for most of the voltage, most of the discharge time, the voltage is in the kind of right around 11 volts or higher. 12 volt, my correction, 12 volts, 13 volts. It's really phenomenal. So charging lithium iron phosphate batteries. This information comes directly from LiFePO4, the little small print when you get one of these batteries. Charging a lithium iron phosphate batteries requires a charger that is made for lithium iron phosphate. These chargers must provide a constant voltage, and they need to be current limited. 14.6 volts is the charging current required for a lithium iron phosphate battery. So shown here on the right-hand side of this slide are the specifications for the 12-volt, 15-amp-hour battery. I've got one over here. And you can see how clearly the output voltage that's required for the power supply is 14.6 volts. The recommended current is 4 amps. Now, the recommended current is written in the specification, but the following piece of information I haven't been able to find written down anywhere. And it is, and you can read it in the lower left-hand corner of this slide, where it says, the guideline for charging a lithium iron phosphate battery is 20 to 25% of 1C, where 1C is the capacity. So a 15 amp hour battery, 1C is 15 amp hour. The guideline is to charge it at 20 to 25%, so that's around 4 amps. So that's what I do, and that's represented in the equipment that I've got over here on the side. Compatible AC/DC power supplies. It's been my experience that for the cost of the power supply, the Bioenno power batteries, power supplies are very competitively priced. I've listed the prices for some of their power supplies and compared them to generic power supplies on Amazon, and to my eye, they compare pretty favorably. Now, if you already have a 30 amp power supply, then you might want to take advantage of the West Mountain Radio Epic Power Gate, which is a pretty sophisticated little box that has internal jumpers that need to be selected in order to match the amperage that's going into the battery. Remember, I suggested 20 to 25%. There are internal jumpers in the Epic Power Gate that allow you to do that. There is USB port access on this Epic Power Gate, so you can monitor it by computer. There's an optional temperature probe, and it supports charging by solar panel. So this is quite a powerful little box. It costs $190. So if you've got if you don't have any power supply and you're going to go out and buy new, $120 for a power supply. The Epic Power Gate runs about $190. You're looking at $310. So my own personal approach, I looked at that approach and I said, geez, do I really need the benefits for my application of an Epic Power Gate? And my conclusion was, no, I don't. And that's why I just use the battery itself and the 4 amp power supply, and for my application it works great with a limitation. The Bioenno battery does come with instructions. They're little instructions. I don't know if you read them. It's the fine print and the little piece of paper that you probably throw away. I read them. So here are some of the interesting pieces of information that I picked out from that little throwaway piece of paper. The first is you cannot, with a lithium iron phosphate battery, rely on voltage as an indicator of battery capacity. In the slide I showed you a few slides ago, you saw that it's really pretty flat for the life of the battery. So it's almost more important to look at the duration. These batteries will not work in series. They will work in parallel, but there's some constraints. In parallel, you should only connect batteries with an equal state of charge. The next bullet point on this slide is pretty interesting, and it suggests that you always charge for at least 5 hours to ensure full capacity. So that's kind of interesting, and why is that? That is because, every battery has multiple smaller cells, and the balancing of the smaller internal cells only happens after time. So the 5 hours allows the internal cell balancing to take place. For long-term storage, the fine print on that little piece of paper says, fully charge, then discharge to 50% of full capacity. Don't leave the battery unattended for more than 6 months. Well, in my particular application, I think I've solved these problems. I leave my battery plugged in all the time to that little 4-amp charger, and it works just great. What size battery to buy? There are 2 factors to look at. One is the required current, particularly the maximum available current you need for transmit, and the other is the runtime, the consumption, how long you want to run your battery. So let's look at that IC7300. Odds are that many of us have it. If you look at the product specifications for the IC7300, I pulled off the internet, it shows you here. During transmit, it consumes 21 amps, at 100 watts. For receive, ranges somewhat between 0.9 amps. Typical, it says, maximum audio is 1.25 amps. Out of being conservative, when I do calculations on expected duration I'm going to get out of a battery, I use that higher 1.25 amp number. So a 15 amp hour, a 15 amp hour battery can maintain a 30 amp maximum continuous discharge. This is another important factor to look at when you buy a battery, and it is this maximum continuous discharge specification for a battery. You want to make sure that the maximum continuous discharge matches the demand that you're going to be putting on it. So for an IC7300, I showed that on the previous slide. What's the maximum continuous current required when you're transmitting for an IC7300? It's about 21 amps. So the 15 amp hour battery is the smallest bioenno power battery that has a capacity that meets that transmit need. So let's calculate runtime for the IC7300. And this is an amp-based weighted average calculation for consumption. While receiving, the transmitter needs 1.25 amps. And for this particular example, I'm going to assume receiving 80% of the time. At 1.25 amps, that means that the average is 1 amp. Transmit is the balance of that time. 21 amps is required. So the total amperage on an average shown there, 5.2 amps per hour. So operating off a battery only, the runtime would be 2.7 hours. The battery capacity, 15 amp hours, divided by consumption, 5.2 amps, times 95% discharge. That's a bit of a fudge factor, but if you remember the discharge curve from the previous slide that I showed, the battery cuts off after about 95% being discharged. So 2.7 hours is the runtime, average runtime. Now I mentioned the 80% that I'm using in terms of receive. That varies a lot. If you're running a PODA operation, that could be 50-50 perhaps, right? If you're operating digital, the FT8 modes, that's 50-50. So that all needs to be taken into consideration. But for my calculation, I assumed it was 80, the 80-20. So average runtime, 2.7 hours. Now, I'm running in this particular mode at home, I've always got the battery charger, that little 4 amp power supply connected. So how much time can I get out of my battery and charger? On the right-hand side of the slide, you'll see the little calculation I've done. We're consuming 5.2 amps average per hour. We've got the capacity of 4 amps from the power supply directly. Remember Kirchhoff's law, the sum of the currents. We get 15 amp hour capacity out of the battery. We get 4 amps out of the power supply. So in my little calculation, the estimated runtime when I'm connected at the house to the house power running the AC is 11.9 hours. And nominally it takes about 3.75 hours to charge. So my constraint, remember there's a constraint for operating in this particular environment, and the constraint is I've got 11.9 hours of operation using the assumptions that I made about 80-20. And if that fits your particular need, then you might do this. Mentioned the mobile application. The mobile application, the same kinds of calculations are applicable. Here I've got a 6 amp hour battery under my car seat. I pulled it out and brought it over here to the table. You can look at it afterwards. I've got it plugged in all the time. Remember I said my car has an inverter, so I plugged in the AC charger. And I'm on the right-hand side, you can look at the calculations. So I estimate that my runtime with the car running is 4.8 hours. And incidentally, if I stopped using the radio, it would take about 3 hours to recharge it. So for my particular application, this works just great. General accessories that I also use, I use an inline meter. An Amazon meter is pretty cost effective for 25 bucks. I use a very low-cost power distribution system. These little plug-in power pole distribution systems that you can get from PowerWorks and other vendors are only around $30 or so. And I also have a battery box. Some general questions regarding the lithium iron phosphate battery from Power. Here's some comments about some of the testing that they've done on compatible chargers for their battery. And I'll let you kind of look at them. There are a number of compatible chargers you can get from Amazon or what have you. I've become really a Power fan. Power makes a lot of offerings on the smaller battery size that are ideally suited for our amateur radio applications. The smaller batteries are easier to carry, easier to put under your car seat. It works really well. Power has an extraordinary 20-year warranty on their battery for being able to provide a charge. And I've known a number of friends who have, or heard about, who've had problems and they've contacted and they've got their battery replaced, no questions asked. So I'm a Power fan. So there you go. That's my approach for battery operation at the home and in my mobile station. Questions? I have looked at, so the question regards what's the impact on temperature and the performance of the battery? And the answer is that other than that constraint that I mentioned about needing to charge at 32 degrees or above, and the lithium iron phosphate batteries with a good battery management system have a transducer to detect that, and we'll cut that off. The operation of the battery does not fall off nearly as fast as it does for a lead acid battery, and they work well in low temperatures. And I've seen a curve that shows that. Other questions about, from Jeff over here?
radio.
Yep, yep. Well, even this charger does have a current draw. And the current draws, and I emailed the manufacturer of this. This has a 13 to 15 milliamp current draw. And while that's not very much, after 100 hours, you know, it is. So in an operation where you'd be using this to charge the battery, I would disconnect it from time to time. But the characteristic of the AC charger in my application, I can leave it plugged in all the time. It is not draining the battery. I don't have a meter on it. And yeah.
So is your inverter just running while the car is running?
The inverter only operates while the car is running. Any other comments or questions? There's one way over in the corner. You have to speak up really loud.
Battery's dead on the mic. What's the effect of letting the battery sit more than 6 months?
The question is, what's the effect of letting the battery sit more than 6 months? I don't know, but very likely it might not hold. I don't know is the answer. What I do know is the factory recommendation from Power, don't do that. That's what I know. And as a practical matter, my experience with these batteries has been leave them on a charger all the time and you'll never be disappointed. That's my experience. Okay, any other comments? Otherwise, Mr. Jeff, you got to head on back up here.
Let's thank Hoop for a great presentation.